Welcome and hello. This is a video exercise in Height 8, and this exercise I have titled Maximum Water Surface Elevation Requirements. This is going to be a standard culvert design where we have to design a culvert beneath a roadway, and the maximum water surface elevation will be set. All right, so we're going to go ahead and talk about some of the design requirements I have in a PowerPoint right here. These are not all of the requirements for the project, but these are some of them, and we'll go through all the other data once we start building in HY-8. All right, so as it shows, the first requirement is that the maximum upstream water surface elevation is 40 feet. So as you can see from the diagram down here, 40 feet is 3 feet below the roadway elevation, which is at 43. So I've got those two elevations labeled. The culvert shape is circular. It'll be concrete. Our three different sizes of circular concrete culvert barrels is 4-foot diameter, 6-foot diameter, and 8-foot diameter. Put a space there. And then the minimum cover is 3 feet, as you can see. And then here are the channel dimensions. So these are the same channel dimensions, this trapezoidal shape right here, for both the upstream end and the downstream end. The only difference is shown right here in the invert, which is either 20 or 22 for downstream and upstream respectively. And what I'm going to use for my first design, just while I'm here in the PowerPoints, is right here. It's going to be an 8-foot diameter culvert, a single barrel, centered along the trapezoidal cross section. So we're going to go ahead and input all of our data, including the hydrology data. We're going to be designing for a 100-year storm event. So I have the peak flow data available for that. And our first design is what you're seeing on the screen here. We're going to start off with one 8-foot diameter barrel centered in the channel. Okay, so let's go to HY-8 and get things started. I'm going to come over here to Project and click on Add New Culvert. And actually, before I do that, let me go ahead and close that. I'm going to make sure my units are US customary. So if you happen to be following along and want to use the exact same numbers as me, then you're welcome to do that and make sure your unit system is US customary. Okay, back to adding a culvert crossing. I'm going to name this crossing Design 1. So right up here for the crossing name, Design 1 is our first design. And we don't have to input this data on the left more than once. What we will be changing with subsequent designs will be just the culvert data and site data over here on the right. Okay, so what do we have here for our discharge? Let's get started with that. For the type, we're going to select recurrence and then click the define button. And I have flow rate data for the 10-year storm event, which is going to be 1800 CFS. Arrow down to the 25-year, that'll be 2100 CFS. And then finally, the design storm is 100-year. So come down here to row number 7 and type in 2350 CFS. So even though the 2350 CFS of the 100-year storm is what we're most interested in, I decided to throw in a couple other numbers just out of curiosity to see how slightly smaller flow rates would result when we run the calculations as well. But this 100-year storm event with a peak flow of 2350 is what we're most interested in. Okay, so click OK. And then the next section down is tailwater data. So this is where we set our trapezoidal cross section. Boom. The bottom width is 8 feet from that diagram. The side slope is going to be 1-to-1. The channel slope is going to be 0.02, so that's a 2% slope. Now, some of this data, like I mentioned, wasn't on that PowerPoint slide we looked at earlier, so you're just going to have to follow along. The Manning channel end value, that'll be 0.035, and then the channel invert elevation. This is the downstream end, so that's going to be 20 feet. Okay. So you can tab off that. You can click on the View button to view the rating curve. That's the data for it. And then if you click on the Plot button, there are our 3 points plotted out from 1800 to 2100 and then 2350. Looks fairly linear to me. That's cool. All right, let's close that up. Next section down is our roadway data. So the crest elevation is 43 feet. Let's type that in. The first roadway station, let's just call that 0. And then the crest length, let's just make that sufficiently long. Maybe 100 feet will be fine. The first drop down here I didn't mention, but we're going to keep it where it is, the constant roadway elevation. The roadway is going to be paved. That's the surface type. And then the top width, I'm going to set that to 58 feet. Okay. So that's it for our crossing data that we don't need to change for every design. We've got that set. Next, let's move over here to the right half of the dialog box where we already have a culvert one that's been created for us. This is sort of a default culvert data. And some of this default data we will be using. For the name, I'm going to give it a little bit more descriptive name. That is 1 by 8 foot at 22. So this 22 here represents the invert elevation of this culvert group at the upstream end of the culvert. The 1 by 8 foot basically means the 8-foot diameter. So we can type that in for 8 feet diameter right there. And then 1 just means that there's going to be one barrel, which is also a default value at the bottom. All right. So let's just go through these one at a time. Name, shape, material, and diameter. Those are all good as we want them to be. Embedment depth, I'm going to say 0 embedment for all of these culverts. And then Manning's N, 0.012. That's correct, straight, and square edge with head wall. Okay, yep, everything else is good here in the culvert data. Next down in site data, the site data input option, we're going to leave that right there at culvert invert data. The inlet station, this is referring to the station number along the culvert now, not the roadway, which is what we were dealing with over here with roadway data. So I'm just going to set the culvert invert station to start at 0. And then after it passes through, the entire length of the culvert is going to be 100 feet. So even though the roadway is only 58 feet, you need to remember that that is up at 43 feet elevation. And there's going to be a side slope down to the culvert. And that's why the culvert length is 100 feet long, even though the width of the road is only 58 feet. Okay, so inlet elevation, I'm going to set that to 22, which we've defined right here. And then after that, we need an outlet elevation that's going to be 20. So we're going to have a 2% slope in our culverts. And that is all we need to do to run the simulation. I'm going to click on the Analyze Crossing button. And what we see here in our results, we have different radio buttons on the left here showing our results. The top option, which is set to default, is this crossing summary table. And we notice that up here we have a row for each of our 3 flow rates. We're most interested in this 100 year. And our design requirement is that we need to have a headwater no larger than 40 feet. So right now, the water surface elevation exceeds 40 feet for all 3 of our flow rates, 10-year, 25-year, and 100-year. The flow through the culvert is only about half of the total flow because see in this column here, we have the flow through our 8-foot diameter circular culvert, and then the rest of the flow is flowing over the roadway. So that's a problem. Because our water surface elevation maximum of 40 is less than 43, then a working design that is acceptable will have 0 roadway discharge and will also have a water surface elevation on the upstream end less than 40 or equal to or less than 40. If we click on the button here for crossing rating curve, here are those headwater elevations based on the flow rate, all of which are above 40. So that is just confirmation that we need to add some more conveyance through culvert barrels to make this design work. There are a few other radio buttons here for culvert summary data. If we select that, we then select the culvert to look at that data. We only have one culvert group right now, so that's all the data there is to look at. Okay, so we can take a look at that once we add another culvert group or 2. I'm going to click close here. And then one more thing I want to do before moving on to design number 2 is take a look at the front view. So I'm going to click on display, views, and then front view. It tells me front view crossing will not be displayed until I set the culvert stationing, and this is referring to the state roadway stationing that that culvert is located at. So to do that, go ahead and right click, define roadway culvert stations, and then between 0 and 100, I need to specify which station number this culvert group is centered at. So I'm just going to say it's centered. So 50 is half of 100. Click OK. And then boom, here is the front view of our one and only 8-foot diameter culvert, which has an invert of 22 feet. So 22 is here, 50 is here, and then our roadway elevation is up here at 43. Okay. So if I click on the specific culvert group right here, 1 by 8 foot at 22, here is the profile view or the side view it's called, where the water surface elevation is way up here at 45 or almost 46. For the headwater, that's too high. It's flowing over the roadway, we want the maximum water surface elevation for our design flow of 2350 to be at most 40 feet. All right. Let's go ahead and move on to our second design. I'm going to introduce this design by going back to the PowerPoint. And then in the next slide, I have design one up on the top and then design two on the bottom. Now, clearly there's lots of different options as to the different size and space of the culverts. But what I'm doing for design two is I'm adding two more 8-foot diameter barrels. This will be its own separate culvert group. So even though it's the same size and shape and material, it's going to have a different invert elevation at 28 feet. The reason why I'm not putting it directly on top of the first culvert barrel is because that would result in less cover. So even though the cover is at least 3, we could go up to 40 feet here. I think it's a better design decision to try to maximize the cover if possible. So that's why I'm sneaking in these two 8-foot diameter culverts below the what would be 30-foot invert, which is the top of this lower culvert barrel, by just kind of putting them on the sides and then lowering the elevation a little bit, if that makes sense. Okay, let's go back to HY-8. So I'm going to click on design one and then right click, duplicate. And then I'm going to rename this design one, just call it design two. So design two. And then I already have my one culvert barrel from before. That's good. I'm going to right click culvert crossing data. Now, as I mentioned before, the data on the left here is fine. We don't need to modify the flow rates or the tailwater condition or the roadway elevation or properties. What we do need to do is add a new culvert group or culvert barrel group over here on the right half of this dialog box. So that's what I'm going to do. I'm going to say add culvert. Okay. And then the name I'm going to give this new culvert group is 2 times 8 at 28. So remember, this at 28 represents the invert elevation on the upstream end of this culvert group. The shape will be circular. The material will be concrete. Diameter, again, I'm going to go with 8 feet. So I'll type 8. Embedment will be 0. Manning's end 0.012. Culvert type is straight. Yeah, that's correct. Inlet configuration and inlet depression is no. So moving down to the site data, culvert invert data will be the method that I use for all of our culverts. The inlet station, needs to be consistent with the existing stationing that we already established with our first culvert group. Since these are a little bit higher up in the embankment, there's going to be an assumed slope. So what I'm going to say is it is 12 feet. That's the station that these two 8-foot diameter culverts that are a little bit higher up are starting at. And I'm also going to say that they end at a station of 88 feet. Okay. Now we know the invert elevation at the start is 28. And then when I did the math to get a 2% slope, the outlet elevation, that's the invert at the outlet, is 26.48 feet. Okay. So there's my 2% slope. The number of barrels, of course, is 2, not 12, but 2. And now I'm ready to click the Analyze Crossing button. All right. So here are our results. This is a similar format that we saw before, except now we have 3 culvert barrels. There's our 1 original, and then the 2 we just added for our design 2. And it looks like the 10-year and the 25-year both have water surface elevations that are less than 40 feet. However, our design storm that we're looking at, the 100-year with a flow rate of 2350, is still just above 40 feet. It's actually 4106. And in the columns further over, we can see the breakdown between how much flow goes through our 1 8-foot barrel at 22-foot invert, and then the 2 that we just added, also 8-foot diameter with an invert of 28. So you can see how that distribution changes. And we also notice that there's no roadway discharge, which makes sense because our roadway is at 43 foot of elevation, and then the water surface at the headwater side is less than 43 for all 3 of our flow rates. All right. If I click on the crossing rating curve button, we're below 40 for 2 of our 3 designs, but the one flow rate that we're designing for here at 2350 is still above 40. All right. Let's go ahead and do one final design, which I think is going to work. Here's our design 2. On the final slide here, I've got a design 3. So design 2 on top now. Design 3. What I'm doing is I'm adding 1 4-foot diameter culvert, which is centered within the trapezoidal cross section. it's going to share the same top elevation of 36 feet. So again, I'm trying to maximize that cover if possible. And I think this will be enough to keep the headwater on the upstream side of the culvert for our 100-year design storm below that 40-foot requirement for the max water surface elevation. Let's go ahead and create this design 3. So back to our HY-8. Here's the main page. I'm going to click on design 2. Oh, yeah, probably should mention this. We need to set the spacing for this before moving on. So right click, define roadway culvert station. I'm going to again say it's centered, so I'll say 50. And then the barrel spacing, I think I have in my notes 12 feet. Let's see what that looks like. Okay, very cool. So right here is the profile view. That's not what I meant to click. Let me click on the front view. All right, here we see all 3 of the culvert barrels. There's the one original one that's red, and then the 2 we added for our design 2 in red now when I selected that barrel group over here in the left panel, the Project Explorer. Okay, so now that that data is set, let's create our design 3. Right click, duplicate design 2. I don't want to duplicate design 1 because then I'd have to add the 2 culvert barrels that we just did. So I'm sort of progressively adding to the last design I created. If I wanted to branch off of design 1, then that's fine, but I just wouldn't have these 2 8-foot diameter barrels that I just added. Okay, so let's go ahead and rename that design 2 copy to design 3. And then I'm going to right click, culvert crossing data. As before, I'm not going to change anything over on the left half for the crossing data, but over on the right, I'm going to add a new culvert group because this is going to have a different invert. It's going to have a different diameter. It definitely requires its own culvert group, right? Instead of culvert 3, I'm going to give it the name 1 by 4 feet at 32. So that represents the invert of 32 on the upstream side. In fact, we can go ahead and just type that in now. So inlet elevation down here for site data is 32. I'm getting a little ahead of myself. Let's start from the top. Name, shape is circular, material is concrete, diameter here. I'm going to change that to 4 feet. Embedment depth will be 0.012, straight, square edge, and no. All right. The culvert data is good. And then down here for the site data, the inlet station is going to be a little bit larger than 12. Now it's going to be 20. So there's 20. It's a 2-to-1 slope is what I'm assuming along the embankment up to the roadway. And then the outlet station right here, this is going to be 80. And then the outlet elevation is 30.8. Okay, so we have another 2% slope in our design. That's all we need to do. Let's see how that additional 4-foot diameter culvert helps our conveyance, specifically for the peak flow. I'm going to click on the Analyze Crossing, and sure enough, that was enough for us. We have the 100-year storm event with 2,350 CFS, now has a maximum water surface elevation of 3994. So that is below 40 feet. That is successful. We can see the distribution of flow through the 3 different culvert groups. It's about 900 CFS through the first 8-foot diameter culvert, just over 1300 CFS through the design 2, the 2 that we added, the 2 8-foot diameter culvert barrels that we added for design 2, and then design 3, 145 CFS is conveyed through that smaller 4-foot diameter culvert barrel that we just added. And again, that's no flow over the roadway for any of our 3 designs. Here is the crossing rating curve. So we're just below 40 for our 100-year storm. That's good. If I click on culvert summary table right here, we can get the individual culvert data. So if we look at 100-year, here's that 900 CFS and some of the hydraulic properties within that culvert. Also, there's some geometry data listed down here, which is also specific to the selected culvert that we have in this dropdown. If we click on the culvert performance curve, this shows the inlet control versus outlet control. Again, this is just for that one culvert. And then if we switch this drop down to say the second culvert group, which is the 2 8-foot diameter culverts, we have different numbers here. Here's our updated flow rate of 1305 CFS. Here are our hydraulic values, and then here are the geometry values, and then here is the performance curve. Okay, just to round things out, here is the 4-foot diameter culvert values. If I'm interested in the water surface elevation profiles, I can click on this radio button here and then click on the selected water profile. To do that, I'm going to also select the 100-year profile from the table up here, the 100-year discharge. And then we can select, how about the 8-foot diameter pipe? Click on selected water profile. All right, so our headwater elevation is right up here, just below 40 feet. You know what? I'm going to go ahead and show this in the other view. So I'm going to click on close that. I need to give this 4-foot diameter culvert a station. So right click, define roadway station. Again, this is also going to be centered. So I'll click on 50 and that should pop into place. Boom, there it is. So highlighted in red. Now this is the culvert we just added. That's 4 feet in diameter. Here are the two that are 8 feet diameter we added for design 2. And then finally the original 8-foot diameter concrete culvert that we had in our design 1. If we want to look at the profile view, go ahead and click on one of the culvert barrels and then click on this button here, or you can go up to view and then, display, view, and then side view is what it's called. The water surface elevation at the headwater and tailwater is going to be the same for all 3 of these culvert barrels. But as I switch between them, they're going to have different either diameters or inverts and different water surface profiles. So the headwater is right around 40 feet. The tailwater appears to be, 28 or something? I could look that up in the table. If I click on the next culvert barrel, it's the same headwater and tailwater, but obviously a different culvert invert. There's 2 of them at this elevation. And then the last one here, this is the 4-foot, also inlet submerged, but the outlet is not submerged. It's a free fall, as opposed to the other 2 culvert groups where the outlet was partially submerged. Okay, that looks fully submerged right there, but that was partially submerged. All right. Well, that's it for this exercise. What we did was have a design problem where we tried to create some circular concrete culvert barrels within this embankment to get a 100-year design flow to be below a specified 40-foot maximum water surface elevation on the upstream side of our embankment.